In the US, there are 2.5 million first responders taking risks every day, many with families. One responder is lost in the line of duty every 2 days. We believe one is too many. That's why we create Eagle Command, dashboard technologies of tomorrow. Dashboard and commanding techniques are used to help commanders maintain needed situational awareness in emergency response. Conventional dashboards involve the use of paper or whiteboard-based methods to prepare notes and tables to organize information about the status of the situation. Eagle Command System is an augmented reality dashboard system to help commanders develop a mind map of what's going on in an immersive, intuitive, and fast response manner. In order to better understand the main requirements for the usability and the function of the Eagle Command System, we performed a series of interviews with the local firefighters from Alachua County in Florida. Meanwhile, we conducted a workshop with fire chiefs in order to understand their current dashboard methods.
The chief is the officer that establishes like a command dashboard, right? The first arriving officer establishes command, but they're a working commander. Like, so they're stretching hose, they're making entry, they're attacking the fire. When the district chief arrives, they may start with paper and pen, and then they go to the back. They have a tray in the back of the DC vehicles they can show you today. They rely on the radio communication with the crews as to their location and the action that they are taking. And then they sometimes transcribe it, I would say maybe most of the time, right, onto a whiteboard to take manual notes. Say engine 3 is doing this action, search and rescue, or what we would say is primary search or secondary search. Engine 4 is, or excuse me, it would be a truck company function, but then engine 4 would be, fire attack. Engine 3, water supply. So they're making those notes. We used to have a program where we could do that, except it took the communication was changing faster than you can make the adjustment with the computer. So it's much easier to just keep track, erase it real quick because they're doing something else, or that unit's coming out and other units going in. The other units have already most likely either gotten there at the same time or before and have started work. So you're in a bit of a hurry to pull out that tray and start transcribing what units are doing based on their radio communications. But we currently don't have any kind of technology our department doesn't have technology that applies a visual of the building and in correlation to where those folks are. We use a designator, which is Alpha, Bravo, Charlie, Delta for the 4 sides of a building, and then 1, 2, 3, 4, for the floors. And then we would transcribe, okay, engine 4 says they're on the Bravo side doing this task. But then we wouldn't have anything really mapping the inside unless we either had a physical map.
A main lesson we learned from the commanders was displaying the locations of people, resources, and hazards in an intuitive way was extremely important, especially for vertical buildings.
So if you were in a 7-story building, it would kind of just see, and that would be dependent upon the relationship of me now telling the incident commander, I'm on, the 3rd floor, Division 3, Division 5. So when we arrive on the scene, what we're looking at typically is just a building. And based upon our training, we know, is that a single family? Is it, is it 2-story, 3-story? So we have and our knowledge of building instruction. Having technology like this with real time, without sending somebody in there, we actually don't know.
Allocentric perspectives, or the third-person viewpoint, are usually utilized for conventional dashboard designs, where the displays are positioned in front of the commander, detaching the commander from the scene. This comes with an obvious drawback, as it can require a significant amount of additional mental effort to convert location-based data into where it is really happening inside the building. For example, mapping victims in 2nd floor room 256 into its actual direction in relation to the commander's current location. As a result, we decided to use augmented reality as our main dashboard solution. This is because AR provides an immersive user interface which can help convert the traditional allocentric perspective of displaying information into an egocentric perspective. With an egocentric perspective, commanders can see through walls to see incidents and relevant information directly at where they are happening at a 1-to-1 scale. This is the so-called method of loci, a method for visualizing, organizing, documenting, and transferring dynamic incident data in their locations as the key anchoring structure. The method of loci leverages the manned pillars concept for simplifying the working memory development of complex events by visualizing data structure as a conceptual manned pillars. When noting and transferring key data, commanders can anchor their memory based on the egocentric perspective of where the corresponding events are happening.
As the lieutenant was saying, like, with a helmet that is capable of withstanding, 1,000 degrees inside of LDH, IDLH, that is, I'm sending a real-time picture out to the incident.
So they're like, all right, so the bedroom and kitchen's here, so they're probably in the kitchen. You go 4 floors here, they're there. I mean, so you were able to pinpoint where to put all your efforts to get it.
Alright, it will be too much to show you all the conversations. Let's just recap the key lessons learned quickly. First, the ideal number for a commander to track is around 7 to 10 units. Anything above this number on our dashboard would be an additional burden. Commanders only want to see the most critical information, such as the top 3 firefighters in jeopardy or the top 3 most dangerous hazards. With that said, some kind of filter algorithms are needed. During the planning phase, they would love to have a configuration page so they can adjust the importance weight for showing the critical information. For example, in one case, the closeness to smoke might be considered the most important factor, but in another case, the heat stroke would be considered as the most critical factor. During the mission, they also want to have the flexibility to adjust the filters and the importance weight with buttons as big as possible. They want to see high-level statistics in the aggregated manner and also individual details attached to each of the assets and the people. So both are needed. We need to have the 2 modes for our dashboard design. And when we are showing information, they would love to see the information somehow matched with their location. So a hybrid display with both information panel and some kind of a miniature 3D map linked together is needed. Fewer colors, bigger icons, bigger buttons. And we also discussed the details of a UI layout, and finally we decided to go with this 4-quadrant design, and each quadrant will have fixed information all the time so they can develop their muscle memory to find the information they need. By the end, we also discussed our special design, the planetary and coliseum design, and the sensor wall, that information going to the places where they're happening, and they love this idea. They want to have this flexibility to switch easily between the 2 modes. We visualize the geospatial data of people and sensors on the 3D map of the building with color-coded objects and the map legends on the left. Individuals are displayed as ovoids on the map, with orange representing first responders, blue for victims, and green for external protesters. On the other hand, the sensors are shown as cubes, with white for structural hazards, red for smoke hazards, and pink for ambient temperatures. Group statistics are displayed on the right side in the occupancy panel and the staging AVL panel. As you can see, the specific counts are listed by the subatoms with an explicit line to indicate the max count. Detailed vital information of individuals can be viewed in these mini panels linked to the ovoids. However, to prevent information overload, we developed a filter function that enables the users to selectively view layered information by category. For example, the user can press the first responder button to only display their mini information panels. The same logic applies to only viewing details for victims or sensors. The user can also choose a specific person on the map to look at his or her vitals by using our slider to select the desired first responder or victim ID to display. Abnormal values that exceed certain thresholds, like this person's 107 pulse rate, will be alerted to the user by emphasizing it in red. Similarly, a red alert will pop out to catch the commander's attention if a first responder is detected as incapacitated. On the bottom left, we see this flashing red alert panel which suddenly appeared to alert the user that the ambient temperature in that area has reached a dangerous level, increasing the risk of heat stroke. Our system will throw alerts for time-sensitive data that requires immediate attention. Other pieces of information unrelated to the task at hand can be filtered out according to the configuration settings. We allow the users to manually adjust what they want to see, and we also provide an automatic filter function that they can use to set with predefined values to display only the most crucial pieces of data, such as information panels for the 3 closest people to areas of smoke. In this way, commanders can focus on what they need to know without having to process extraneous information, which may contribute to cognitive overload. In addition, by integrating the location data of people and sensors with a light-up point cloud, commanders will be able to see a holistic view of the situation and gain a greater understanding of the bigger picture. Displaying data like this in 3D also allows commanders to get a 360-degree view of the building from any angle, zoom in and out on different areas to get a closer look. To fully maximize the advantages of having a 3D point cloud model and the location-based data, we combine the GIS data with the AR environment to create 3-dimensional rendering of the buildings atop their actual geographic location. Our system is capable of directly ingesting latitude and longitude coordinate data for usage instead of needing any data translation. This also means that the new location-based data sources can be easily added without having to restructure too much of the code. We also support switching the map between 2D and 3D formats to provide a visualization of the landscape with elevation data, which is key information needed by commanders for an evaluation of the current situation and the management of the search operation. We integrated a high-precision 3D point cloud model into the GIS system to create seamless information transactions between the event space and the offset environment. This is the planetary mode, the 2D information canvas to show the high-level statistics of the entire incident. It includes the personnel information, that is the complete list of first responders on site, the resources in need, and also the instructions given by the commanders to each of them. It also has the camera view streaming from them. It also includes the environmental information such as the overall temperature, the sensor information with their locations, and the warnings. And the warnings include the top 2 first responders in jeopardy and the top 2 warning from the environment. And what are considered as warnings totally depend on information provided by the commander through the configuration panel.
When considering our data architecture, we wanted not only to focus on building a client that ingests data given to us, but also design a robust data solution pipeline that can be quickly implemented. While many factors affected how we designed the pipeline, we believe the key factors to be flexibility in the data streams we ingest, persistency in the data streamed, and the security of that data. As shown in the UML diagram, we use the cloud, specifically AWS, to implement many features we believe are important. On the left, we have a variety of data we believe is currently being sent or may be sent in the future. All this data is routed to a Lambda function, which converts it into the needed format and stores it in DynamoDB. Upon storing the data, another Lambda function retrieves the latest data and processes any necessary metrics before sending the data to the client to ingest. This data solution allows us three main advantages: distributed data streaming, data storage redundancy, and data lifecycle security. Distributed data streaming means that we have the ability to handle and ingest multiple streams in parallel. By implementing this function asynchronously, it allows us to accommodate new additional streams faster and prioritize certain data streams to adapt to bandwidth limitations. We reduce startup times for the client, as the client does not need all data to begin working. Data storage redundancy means that data is automatically duplicated, allowing the data to be available always without possibility of loss. Cloud infrastructure allows the data storage to be scalable based on needs. With strategic duplication, data can be made on servers closer in physical distance to the client, reducing latency. Finally, data's total lifecycle security means the data is encrypted both at rest, when stored, and in transit when being sent either between cloud infrastructure or to the client. Data is only decrypted upon read, reducing the possibility of the data being read by unauthorized users. There were three key features we worked on in our prototype. Our defining feature is our Coliseum mode, which presents a first-hand point of view of the emergency situation with a 1-to-1 scale, so that emergency commanders can see through the wall and into the building. Emergency commanders commented that having the Coliseum mode allowed them to identify building and entry points faster and more naturally. In addition, we have implemented a filter functionality that classifies different statistics automatically. Prioritization of statistics via fuzzy algorithms, in addition with wayfinding algorithms that calculate possible triage routes, aid not only in presenting information to the commander, but also possible solutions. After hearing back from commanders the importance of keeping up to date with the status of all resources on the scene, we realized that automating status updates via natural language processing algorithms would allow commanders to focus on strategizing resources rather than spending time noting down statuses, giving commanders truly continuous capabilities.
I thought that was interesting from the standpoint, if I could put in there are my responders and there's a victim, I would want to see it big like that.
Yeah, that would be awesome.